Welcome to FYI, the Four-Year Innovation Podcast. This show offers an intellectual discussion on technologically enabled disruption, because investing in innovation starts with understanding it. To learn more, visit arc-invest.com.
ARC Invest is a registered investment advisor focused on investing in disruptive innovation. This podcast is for informational purposes only and should not be relied upon as a basis for investment decisions. It does not constitute, either explicitly or implicitly, any provision of services or products by ARC. All statements made regarding companies or securities are strictly beliefs and points of view held by ARC or podcast guests and are not endorsements or recommendations by ARC to buy, sell, or hold any security. Clients of ARC Investment Management may maintain positions in the securities discussed in this podcast.
Welcome to ARC's FYI podcast. That's Four-Year Innovation. My name is Sam Corris. I'm one of ARC's industrial innovation analysts focusing on aerospace. Today we've got a great guest. We've got Blake Scholl, the founder and CEO of Boom Supersonic. Blake, would you care to introduce yourself and tell us a little bit about Boom?
Sure. Well, thanks for having me here. Excited to be continuing to do this despite the pandemic around us. I'm founder and CEO of Boom Supersonic, which is aiming to create a renaissance of high-speed travel, to pick up kind of where Concorde left off a couple decades ago and build high-speed aircraft that are available to more people in more places, ultimately allowing us to do things like New York to London in 3.5 hours instead of 7, or across the Pacific in 5.5 hours instead of the 10 or 11 it takes today, enabling you to go more places more of the time and helping create a more connected world. And I think at this time when the world is perishing from a lack of connection, when we've had to distance ourselves, when everything has gone virtual, it's a poignant moment to be working on technologies that 10 years down the road, or maybe even a bit sooner, will allow us to be far more connected than we have been in recent memory.
I think that's absolutely right. And I think latent demand is something that people often forget. It's not just taking the existing market and saying you can get there faster, but once you transform transatlantic flight to equivalent of flying to the Midwest, that really opens up a huge amount of opportunity.
It really does. I appreciate that you said that because it's a widely underappreciated point. If you think back to the early days of Uber, people asked, well, what percentage of the black car market in San Francisco did Uber take? Oh, was it 10%, 30%? Maybe if they did really well, it was 35%. The actual answer was 300%, because they took something that was painful to use and made it so much more convenient that demand exploded. And I think we're going to see the same thing with high-speed travel. When we went from propeller aircraft to jets 50, 60 years ago, travel to places like Hawaii actually skyrocketed. It went up like 6-fold in 10 years. Because when you make something more accessible, people go more often. I think we're going to see the same thing with supersonics. It's latent demand, just like you said.
Yep. And that's the future promise. But I guess to start things off, let's look back. You mentioned the Concorde, right? That had its first commercial flight in 76, I believe. There was one other supersonic jet from the Russians at the time, but neither of those really panned out. What happened with those and where are we today?
Well, I think it pays to look at where innovation comes from and where's the state innovation comes from. And for the first, call it half century of aviation, from the Wright brothers forward, it was largely commercially driven. Why did the Wright brothers build the aircraft? Well, one, they thought it'd be awesome and they could figure it out, but they also thought there would be a business there, that there would be a practical use for the airplane, that they could sell them or they could earn money demoing them. And that was the pattern of the other key innovations in air transportation. The first practical airliner, the DC-3, was built by Douglas because he thought he could build an aircraft that a lot of people could afford to fly on, and airlines could operate profitably. That drove innovation. And then in the 1960s, amidst the Cold War, the impetus for aviation innovation changed. And it went from, let's build products that people can use and operate profitably, to let's show that Western technology is superior to Soviet technology. And so in the early 1960s, you had supersonic projects spring up both in the US, in Europe, and the Soviet Union. And so that the Soviets had the Tu-144. Concorde was a joint venture between the French and British governments. Remarkable that it ever actually flew, because most joint ventures between the French and British historically have been wars, right? Not airplanes. And then there was an American competitor as well that's often forgotten. That was called the SST. And it was supposed to be faster and bigger than Concorde, but the plug got pulled for that. It was kind of behind budget and over schedule. But coming back to Concorde, it was technically remarkable what they were able to do in the 1960s, but there was no requirement of a business model. So what they had to do was go fast, try not to crash, and try to do it faster and better than the Russians. And so that was all they had to do. And so they built something with 1960s technology that was impressive, but it was a gas guzzler. It required sky-high fares. There's something like $20,000 in today's money. 100 seats to fill on the airplane at $20,000 a pop. You can't find enough passengers to fill it. And it never made a whole lot of economic sense. It never got to economies of scale. And so after flying for 30 years, it got shut down with no plan to replace it. And I think that story is really emblematic of the difference between privately driven, economically driven innovation versus national prestige-driven innovation. There's another story that goes just like this one called Apollo, where literally around the same time period, we put men on the moon. And 50 years later, if you go to, if you want to see a moon rocket or a supersonic airliner, you have to go to a museum rather than looking up in the skies. It really goes back to the importance of the capitalist approach and of going about things in ways that has sustainable economic models and sustainable environmental models. And so the political fallout of Concorde was we actually had a ban on supersonic flight over land in the U.S. And that only came about after the U.S. competitor to Concorde was canceled. It was like, it was great when we were going to win this race, but after that, we can't have any of the sonic stuff because only the Europeans and the Russians have it. And then that created kind of a blockade to business models afterwards. It's what normally happens in innovation, as I'm sure all of your listeners appreciate, is things start for relatively small markets at relatively high price points. Think early computers, think electric cars, think virtually every innovation. And then as we figure it out, we get economies of scale and we figure out how to make it less expensive and it gets available to more and more people. And what would have happened with supersonic travel was it would have started out as a private jet for people whose time was worth the most. Smaller aircraft where fuel burn is less of a consideration. We figured out how to make the sonic boom quiet enough that it wouldn't be a problem. And then that would have grown into a small commercial aircraft, and then a large commercial aircraft, and then faster ones. And we'd all be going, Mach 3 or 4 by now. But instead what happened was, thanks to the political fallout from Concorde, we banned supersonic flight over land, which means the natural starting point for that market with a supersonic private jet didn't exist. And you couldn't justify the R&D for it. And so we had decades of stasis until we've reached a crossroads really very recently, where there is now the intersection of what you can do technologically and what you can do, what the current market will support. And so that's where you get to the boom story, where we're saying, let's not worry about the supersonic flight over land. Let's focus on routes that are over water. Let's kind of skip over that first innovation node of a private jet and go straight to a small commercial airliner. And today there's the technology to do that, as well as the market demand to make it reasonable.
And I'd love that analogy to the rocket industry. I mean, really, even more recently, SpaceX with the Falcon 9, the price point that they came into was not revolutionary. It was actually what the United Launch Alliance was charging before they bloated costs over 2 decades because they're a monopoly.
Isn't that crazy?
It is insane. So I think that's a perfect analogy there. And then if we can, you mentioned this was all 60s tech that made supersonic possible. We've clearly had half a century of advancement since then. What are some of the technologies being used now versus then? Or is it still kind of leveraging that as the foundation?
Well, the ironic thing is, since Concorde flew, we've changed basically everything about airplane technology except the speed. So we've gone from aluminum to carbon fiber composites. We've gone from designing on drafting paper with slide rules to computer-aided design. We've gone from testing in wind tunnels to testing in computer simulation. We've gone from afterburning turbojets that are loud and gas guzzling and incredibly environmentally unfriendly to turbofan engines that are much quieter, much more fuel efficient, and way more environmentally friendly. And coming back to this crossroads point I was making earlier, if you put all those technologies together, things that have been proven and are actually flying on other aircraft today, you can recombine them into a new design that's going to give you a revolution in speed. It doesn't actually require anything scientifically or fundamentally technologically different. It just requires putting together things we've already proven and building a new business model and a new design aircraft.
All right. And then to dive into what exactly Boom is doing, right? You have the XB1, the baby boom, if you will. Can you talk about that project? And it's expected to fly this year. Is that still true?
It's expected to fly next year. So
next year, okay.
we're in the process of final assembly as we speak. It'll be finished over the summer, and then it's about a year from assembly finished to being in the air. You do all the testing you can on the ground before you go put it in the air. If anything's going to break, you want to know it while you're still firmly on the earth. But zoom out a little bit. So we've taken on what is obviously an ambitious project for anybody to do, and taking it on as a startup company somewhere between audacious and crazy. And so how do you actually go about that? You do it step by step. I'll start from the first product, and then kind of work backwards to how we're attacking it. So the first product is what we call Overture, which you can think of as the minimum viable supersonic airliner. It is kind of the simplest, most technologically feasible, most proven technology version of a supersonic airliner that we think has a big market. And so what is that? It's about 55 to 75 seats, and it's aimed at passengers that would fly in business class today. So that the folks who would, fly on those lay flat beds and the front cabin of an airplane, where they're paying an extraordinary premium to be able to sleep on the airplane because the flight is so bloody long. And the idea of Overture is we'll get you there in half the time, and so fast that you don't need to sleep on the airplane. You can sleep in a real bed, before you leave, and then catch your flight. And you'll be able to do that at fares that are similar to what you'd pay in business class today. So that's the first product airplane. But it's a 200 to 300,000 pound vehicle. It's one of the most complex safety critical machines ever created. And so what do you do as a startup company? Well, you don't go just straight away and build that. You go build a subscale prototype with an obtainable amount of money and a reasonable amount of time that lets you go prove what you're saying, that all the technology is really there. It also lets you prove that your team can do it. And it lets you learn a heck of a lot along the way. So you make mistakes when the scale is small and the capital involved is relatively small, such that when you go build Overture, you've already paid the tuition, you've already learned the lessons, and you're much more likely to have a smooth path through development, certification, and then carrying passengers. So that first aircraft, as you said, XB1, or sometimes we call it Baby Boom for fun, is well on its way. So it's in final assembly now. So the forward fuselage is nearly complete. We are a couple weeks away of putting the wings together. The wings just finished wing testing. There's that, that wonderful thing where you load up the wing with hydraulic actuators. You take it up to the loads it'll ever see in flight, and they bend, and there's a little bit of popping, but you hope there's no snapping and cracking. And then you feel a lot better after that finishes successfully. Those are tested. They're about to go together. The engines are in the hangar. The last few parts are getting fabricated. Aircraft will roll out on its own landing gear here in a few months.
That's awesome. I also love the timing of this because I'm currently reading Skunk Works, which is the great tale of Lockheed Martin trying to build the first stealth plane. So, all of this is resonating a lot with the struggle and all of the testing steps in order to do something like that.
Wonderful book. There's also, if you love that one, there's another one. I'm blanking on the title, but was written by Kelly Johnson, the founder of Skunk Works. And then the book you're referring to was written by Ben Rich, who was his protege and successor. I think it was more than my share of it all. I think that was the title.
Awesome. I'll have to add that to the list. And then you're talking final assembly. I know that one of the things that Boom is doing, and that a lot of aerospace is starting to do, is utilizing a lot of 3D printing. Can you talk about how you're using that and why that as opposed to other traditional manufacturing techniques?
Yeah. So I'll talk about what we're doing right now, and then I'll come back to the aircraft. So right now, we actually stopped 3D printing parts for the aircraft, and we're 3D printing parts for face shields for local hospitals. So we've been able to contribute to about 500 or 600 face shields now that are really making a difference for local hospitals during the COVID pandemic. So I'm really proud that we're able to do that, and our team just stepped up and started doing it. But ordinarily, so we use 3D printing both for aircraft parts as well as for tooling and assembly fixtures and jigs. The reasons it's valuable are, I think, widely understood. You can enormously reduce the time required to go create an article. And so what that means is you can get to prototype parts or even production parts much faster than you could with traditional manufacturing techniques. So for example, we have a relatively complex mechanism on the aircraft called a ratio changer, which is this component of the flight control system that's basically the gearing system between the pilot's control stick and the actual control surfaces on the airplane that make it roll and dive and climb and whatnot. And it basically, as you accelerate, those gearing ratios change. And so you implement that gearing in physical hardware rather than in software. That way it's really, really reliable. It's not going to hit an edge case and crash the airplane. So you do it in hardware, but it's an expensive thing to go create. And so what do? You 3D print it first, and then you play around with it. You make sure it's doing what you want it to do, and it doesn't bind up in ways you didn't expect when you're looking at the CAD screen. And so that allows you to get a lot of confidence in the part before you go invest in building the flight hardware. So that's one example use case. Another is in the manufacturing process. You've got enormous number of holes to drill and fasteners to put in, and they have to be extremely precisely precisioned. And so you want these kind of tooling jigs that will basically provide like drill holes for you to go drill in exactly the right places and will conform to the surface of the aircraft where you're going to put it. So you can put this drill block up there, kind of get it exactly where you want it, and then just mindlessly go drill the holes and you're all getting in the right place. Doing that in a traditional process would be incredibly expensive, incredibly time consuming, but you can just make those in CAD really easily and press print and they pop out and then they're ready to go overnight. You're saving thousands, if not tens of thousands of dollars, and you're shortening a 6-week process to like an 8-hour process.
That's pretty remarkable. I know on Twitter, I saw there's a photo and there's a bunch of Stratasys machines and parts. Was there anything that drew you to Stratasys as opposed to some other 3D player? What's kind of that process look like for you?
Stratasys has been awesome for Boom, and they've been an official partner for a long time. They've been in 3D printing a lot longer than people have realized it's been around. I think they've been around for about 30 years. And so really being able to do this in industrial scale and industrial quality is something they're awesome at. And so we have 3 different Stratasys printers, a small one that we use for prototyping all the way up to a large where they can do a whole bunch of parts at the same time for production quality. The machines work great and the support's been awesome. And they've partnered with us on this face shield thing. Like they gave us all that material for free to contribute to that effort. A lot of the 3D printers that you think about are kind of the small hobbyist kind of market, but you want a lot of precision, you want a lot of repeatability, and you want predictable material properties for parts, for example, they're going to fly. So we've got, as an example of what's on the airplane, the brackets that hold the environmental control system ducts in place, basically the brackets that hold the air conditioning ducts are 3D printed, and you got to be sure they're strong enough. And so having printers and material systems that are well qualified such that the thing's never going to break and it's as strong as it needs to be matters a lot. And Stratasys has done a lot of the heavy lifting to make that feasible.
And I think what you said is also something that's underappreciated is it's this transition from 3D printing as prototype only to quality that's good enough for actually end use parts, where there's obviously huge opportunity in aerospace where every ounce of weight has huge ramifications. And obviously you need high standards to meet for strength and durability.
That's right. Yeah. And there are many cases where you can 3D print a part that will enable a design that you otherwise couldn't create that can make the overall strength to weight ratio better. And in aerospace applications, like you said, weight is incredibly important, and you do everything you can to get it out, and 3D printing enables additional weight savings.
Yeah, I wonder, so for the computer-aided design, and as you said, right, 3D printing allows these new shapes. We hear from some of the larger incumbent companies that it just takes a huge amount of time to actually reframe the thinking of the design team in order to think differently and not just use this new technology in the same old way. What does that process kind of look like from the design standpoint?
It's totally true. Our experience has been that there's a little bit of formal training that you want to do, but one of the most effective things is just to make the printing technology available to your team like a toy. The right culture and the right people will just geek out on it and they'll learn it themselves. The 3D printers in the office are available for anybody to use, and there's a sign on them that says how many dollars per cubic inch it costs the company to print something. And that's just so everyone can be situationally aware, but you don't have to go through some budget process to deal with it. Just, put your Boom hat on and be a good steward of our capital. And what happens is people go come up with stuff. They play around with it, and then they tell their colleagues about it, and everyone gets excited. And then that spurs a lot of the innovation and kind of changes in how you think. But a lot of that comes back to just building the right engineering culture. And that's been one of our biggest areas of focus at Boom. If you go hire a theoretically super experienced team top to bottom, the stodgy aerospace companies that never managed to make supersonic flight happen, then you're going to get, we're going to do it the same way we've been doing it. And what we've deliberately done is built a culture that's a mix of young, enthusiastic talent with the right kind of experienced people from elsewhere in the industry. That combination, it's difficult to forge, but it creates some real advantages because you've got the people there who can help you see around corners, who can help you not make what are the classic mistakes, but also the folks that don't know what's impossible and can go try new things and do them differently and better.
That's a huge part of innovation.
Yeah, I'll give you an example of that. So like we were saying, weight is critical on the aircraft. And it turns out to be critical not just from, we have to make it as light as possible, and that's technically challenging, but how you manage the weight budget turns out to be an important management tool. We started out doing it the way it had always been done in aerospace. We had a weights engineer with a great resume. They built a model, but it turned out it was like garbage in, garbage out. And we didn't really know where we stood. And we thought we were in a better place than we were at. It was honestly, it was a bit of a mess. And then so we threw all that out and we said, let's just start over from first principles. Instead of putting a weights engineer in charge of weight, we had put a finance person in charge of weight. And we got called crazy. But we said, look, this is an accounting problem. It's a forecast problem. It's a P&L. And so we built a weight P&L, and then we put some automation around it such that was updated in real time out of our CAD database. We put it on a big screen where everyone could see it. And all of a sudden, the weight problem went away. Those people knew exactly what they needed to attack. They knew exactly where we stood relative to where we needed to be. We knew where we had positive margin and negative margin. And the team rallied around it. And then it was like, oh, it actually turns out, yeah, finance people should be in charge of weight.
That's incredible. So what's been the best toy made from the 3D printer so far?
Oh, the best toy made from the 3D printers. We have cookie cutters that let you make XB1 shaped cookies.
Oh, that's great. You got to put those up on the store.
We really should, yeah.
And then while we're talking the finances side and looking at it from that angle, I think a super interesting thing about Boom is we're in the investment space, not on the private side right now, but normally VCs are pretty shy from these capital intensive, hardware centric type businesses. But obviously it's a huge opportunity that you're tackling. What was the journey there, and what was kind of the feedback, or what was the sense you got from venture capitalists?
Yeah, so fundraising has been one of the more interesting challenges in this business, because it's the kind of business that sounds like a bad idea, but if you deeply understand it, it's actually a great idea. But it defies a lot of conventional wisdom. So it's technologically complex. It's in a space that's highly regulated. It's necessarily long gestation. It is capital intensive. And so that's something that a lot of people just boot up and say, oh, that's going to be a horrible idea. Oh, yeah, most airplane startups have not been successes. The last one that really worked was Douglas Aircraft, founded in 1921. But what we found was that a lot of the conventional wisdom is false. And if you take it to the right people and explain that to them, they get incredibly excited. And so the art of doing this, it comes back to the thing we were talking about earlier about how you have to have a business model that's sustainable. And so that applies on all sides of the business. So we have to build an aircraft that the public can afford to fly on, that the airlines can operate profitably, that our suppliers can make money building parts for, and that our investors across all stages of the business can see a great risk-adjusted return. And so what you have to do is really put together a systematic financing plan from the seed round all the way forward, such that you understand how you're reducing risk in the business in a way that investors can perceive, that allow you to kind of get your valuation up and stage your capital raises such that you're raising on the heels of milestones and able to access large amounts of capital without diluting out yourself and your investor base. And so if you're well organized about that, you can do it very well. And in a certain sense in this business, you have to raise the last dollar in order to raise the first dollar, because the smart people who have invested in Boom, and I can't name all of them, but much of our capital has come from not venture capital funds, but some of the most well-known partners and well-known funds who invested outside the fund. And the first question they ask you is, how are you going to get the money together for all this? And you show them your plan of, this is how I'm going to systematically reduce risk, and this is what that milestone will be. And if I build this aircraft and it flies, I think the company is worth X, and then I can raise on Y, and you won't be diluted, and here's how it all works. You explain that all to them, and then they're on board. But you have to find folks who have access to capital that's impedance matched with the business model of the company. This will be something like 15 years from founding to exit. And we started in 2015, and our rough plan is fly the first commercial flight from London to New York with the first passengers on it, and then ring the opening bell in the stock market that morning. Maybe we'll ring it in London, then we'll ring it again in New York the same day.
That's amazing.
That's my little personal fantasy. But that's a 15-year process. And so if you've got a venture capital fund that's looking to exit 5 to 7 years, it doesn't work for the early rounds. And so you have to find the right capital sources for the right stage of the company. And in the early days, it was ultra high net worth individuals. Then we started to bring in strategics. So for example, Japan Airlines invested in the company as part of pre-ordering aircraft. That was huge for us. And then as we look at the next bit of capital coming forward, we'll likely also start to bring in some more institutional capital, as we're now getting proof points like this aircraft coming together that show this is really happening. The plan is working, and getting close enough to exit that it starts to make sense for funds with 10-year horizons.
Wow. Thank you so much for sharing that. I think it's super interesting because, right, it does require that long-term vision. And that's often what we say pretty much with most innovation is it's inefficiently priced, because people tend to have such a short-term time horizon and underappreciate that investing now for these huge opportunities down the line really can pay off tremendously.
It's true. And it's also true that there's more of a herd mentality in venture capital than you'd really like or expect. I think that has to do with the dynamic between VCs and LPs. There's nothing other than Blake's theory here. You may know better than I do on this. You want to go show your LPs that you're doing things that make sense. And the easiest way to do that is to pattern match off of things that worked. And so if you want to go start a rocket company today, you can actually do that with venture capital because you can go down Sand Hill Road and you can point to SpaceX and say, that worked. That was a massive success. Don't you want to be the next one of those? It's something that no one looks too silly doing. But there is yet no airplane company you can point to and say that was a massive success. That will be Boom. And so it becomes a harder thing to defend. And in a world where you've got an investment committee or an LP committee, you don't need that many no's or nervous to get to know. But if you can find those right pockets of mavericks with access to their own capital, then you can make it work.
And then to touch on the sustainable business model, because I think that's also another really important point there. I mean, and we'll get to this later, the hypersonic touting of some companies or rocket point-to-point travel. But really the private flight market is driven by time saving. A lot of people do it so that they can save the time at the airport. Most of the flights are pretty short haul, so you can schedule it when you want. And people are really willing to pay significant premium for time saving with flight. And so obviously you guys are looking to cut transatlantic flights times in half. And our modeling would suggest that people on average, if you're comparing it to the private flight market, pay roughly $15,000 extra for every 2 hours saved. What are you thinking about from the business model standpoint? What does pricing look like in your mind? Or have you not gotten that focus on building the plane first?
It's a great question. And boy, airlines would love it if we could monetize this at $15,000 for 2 hours of flight savings. This would be a flying mint. In my view, it's really hard to forecast exactly how the market's going to respond to this because it's involved behavior changes. And what can you extrapolate from? You could extrapolate from what goes on in the private market. You could extrapolate from what premium people paid commercially to have a nonstop flight versus one where they have to change planes. But there's nothing out there today that is as dramatic a time savings as what you'll be able to get for supersonics. And to paint that story, there is a threshold that's somewhere in the vicinity of Mach 2, somewhere between Mach 1.8 and Mach 2.2. Something magical happens, which is you can switch red-eye flights to daytime flights. And when you do that, the time savings in the air compound and it turns into not hours saved, but days saved. Pick a couple examples. Let's say you're in San Francisco and you got a Monday morning meeting in Tokyo. Today, you have to leave Saturday. You get there end of day Sunday, Tokyo time. You try to sleep in a hotel. Then your alarm goes off Monday morning. You try not to sleep in your meeting. And then you go catch a flight back after your meeting. The whole thing takes 3 calendar days. And you better not make any decisions the rest of the week because you're jet lagged and all kind of messed up from that. And so when that 10, 11-hour flight shrinks to 5.5 on supersonic, what happens is you can do the whole thing in 24 hours. And so instead of leaving Saturday, you leave Sunday. A morning flight from San Francisco to Tokyo arrives Monday morning. To you, it feels like Sunday afternoon. So you're awake, they're awake. You can do basically a whole day of meetings. It's a bit of a long day for you. You're tired at the end of it, but you got through it. Catch an overnight flight back, sleep on the way home, and you're back 24 hours after you left without any jet lag. And so what will people pay for that? Like, there is no analog today. There's nothing you can compare that to except propeller aircraft versus jets. And we all know that propeller aircraft basically went away. So that said, what do you do with your business model? This is an audacious venture overall. And so what you have to do is make conservative assumptions everywhere so you're not loading the business up with risk. So our point of view is that we do our modeling based on fares that are like business class today. No premium to a relatively small speed premium. That's likely low. But if you can build an aircraft that's profitable at fares like what we charge today, then that's a no-brainer for airlines. And it's much more straightforward to say, well, what percentage of the market's going to choose a shorter flight and a longer flight at the same price point? Well, 100%, or maybe more than 100%. And so that makes it more of a clear value proposition. But the actual, especially in the early days, there's going to be a lot more demand than supply. The clearing prices will be high.
And then I guess looking further, or I guess we'll set it in the framing of competition. What do you think about Virgin Galactic's long-term plan of hypersonic or SpaceX's plan of orbital point-to-point transport? Obviously, very long time horizon. But what do you think of those types of activities?
So it'd be great if they worked. And we're good friends with Virgin and Virgin Galactic. Virgin was actually our first pre-order customer for Overture. And Virgin Galactic has been a close friend of the company. But what's different here is what time horizon you're talking about, what price point you're talking about, and what level of technological development is required. And so things like point-to-point travel, via space are several breakthroughs away from working. Like if you look at what would be required to do it point to point at business class fares, it's a 3 order of magnitude cost reduction from what's achieved in the Falcon 9 today. And not to mention the safety challenges that you'd have to overcome. And like all that can be overcome, but it's not happening next year or the year after. The Boom approach is, we think the world could have used this a while ago. So let's focus on technology that's proven safe, reliable, and efficient and get that up and running. Then take everything we've learned from that and the capital we've amassed from that, and then go plow that into the next set of innovation. One of the things that's really exciting is when you shorten flights, like you said, you unlock latent demand. And so that means more people going more places more of the time, which begets larger aircraft. So we're starting out in this 55 to 75 seat range. But as you see more demand materializing, you can justify a larger aircraft. And as you do that, you can actually make it more efficient, which means the cost can come down, the fares can come down, and you can have even more demand. And so you start this flywheel where faster speed begets more demand, begets more efficient aircraft, begets more demand. And if you get that flywheel spinning and you start to take some of the capital generated and invest in fundamental technology, you can further push the envelope on speed and efficiency. And you can get this flywheel going that will ultimately give you, Mach 5 or whatever at economy or better than economy fares. But you have to start somewhere. And our view is the best place to start is proven technology, known ability to make it safe, and the largest market you can figure out to hit with that.
Makes sense. Got to walk before you can fly, I guess.
That's right. And the Virgin Galactics of the world have a different view of this. They're starting with space tourism, and then they're trying to extend the legs of that platform. That ends up being a much, much smaller market out of the gate. If you're talking about who can pay $250,000 for a 10-minute ride versus what we're doing, we see this being for tens of millions of people out of the gate.
Right. Definitely a larger addressable market at lower price point. From the fuel efficiency side, what does that look like? Is the cost breakdown still similar to a traditional plane with the breakdown between fuel costs, pilot, and everything there? Is it kind of flipped around?
So it's interesting. So when you go faster, the things that are challenges are fuel efficiency and maintenance costs. Those are the two cost areas where you really have to innovate and get them down. But what's interesting is everything else, from catering to crew to rent on the aircraft, is proportional to hours, not to miles. And so when you go faster, all those costs naturally drop. We call that the speed dividend. So if you make enough progress in fuel efficiency and on maintenance, then the speed dividend kicks in and you can actually see cost benefits from going faster. And this is part of the reason why those propeller flights that existed before the jet age don't exist anymore, as the speed dividend of jets made them a better overall economic package. So to come back to fuel efficiency in particular, our target is to match the fuel efficiency on a per seat mile basis of subsonic business class. And so what that means is you can have a lie flat bed, a subsonic, or you can have a nice size seat with a flight half as long, and it's going to cost about the same fuel, the same overall operating cost.
Wow, that'd be pretty incredible. I have a question. This is something I always wonder. Every time I get onto a plane, you look at an airplane seat, and I'm always just like, I don't understand why the seat is built like this. It seems like there's obviously there's tons of safety regulations and things like that, but it seems like there's huge room for improvement on the airplane seat itself. I'm wondering if you guys are tackling that or what your thoughts are on that, or if I'm just being complainer, being, a tall person on a plane.
You can definitely do better than today's airline seats, no doubt. And so we've deliberately taken an unconventional approach there so that the team that is forging ahead on that design had never done an airplane interior before. That's on purpose. We wanted to break the mold, get some great designers that were not steeped in the way it's always been done, and use that to create some vision for it, and then bring in the airplane safety certification expertise to start to imbue that design with the realism that it needs to have to really fly. That opens up a lot of opportunity. So what we're building is a seat where the design goals are to enable you to work, to relax, or to be entertained, but not necessarily for you to sleep because the flight's too short for that. And so you end up with a nice big personal working space, a great big tray table. My personal favorite feature is a cup holder that's nowhere close to where you put your laptop. That would have saved me a couple of times. And a great big window, because the only thing that's good about being stuck in a tube at 60,000 feet is the view is going to be amazing. So you put those things in place. And then there are a lot of other sort of just detail and care level innovation you can put into it. Like one thing we're looking at is how can you build tray tables that disinfect themselves? Can you put a UV light in there and such that it's well known that tray tables are approximately the most disgusting thing on earth, especially when we're thinking about how germs spread. Can you build an aircraft that's pandemic proof? Just by building in the right technology here and there. There are 1,000 details like that matter, and you have to care about them. So think about the experience when you walk on board an aircraft today, and is the PA volume reasonable, or is it too loud or too quiet? Is there that like weird humming noise that comes from the lights or the hydraulic pumps or from the air vents that are noisy? The whole experience today just exudes stress. It's stressful of like, are you going to make your flight? Is it stressful of how long is the security line going to be? Is it stressful of like, is there going to be overhead bin space? And we want to flip that around and have the emotional theme be tranquility, at least from the moment you step on board the aircraft to the moment you step off, because that's what we control. And so that's things like really sweating cabin noise, really sweating the PA system is calibrated well, and it's not too loud in some parts of the aircraft and too quiet in others. And honestly, the volume control is in the right place. I once complained to a flight attendant about the volume being too high. She's like, we can't change it because the volume knob is down on the nose wheel and you have to get maintenance to change it. I'm like, wow, okay, let's not make that decision. And then you can do things with baggage. So the Overture onboard baggage design has one bin per passenger. And so you don't worry about whether you have to get on the plane quickly in order to have a place to put your bag. There's a place reserved exactly for you where your bag goes.
That's terrific innovation, and something so simple that it just takes it's exactly like you said, new DNA required to come in and rethink it without having preconceived notions. As we wrap this up, what should we and the public be looking for as the next milestone from Boom Supersonic, and how can people follow along with the progress?
Yeah, great questions. So the next major milestone you're going to see is rollout, which will be later this summer. And that's where we will unveil the completed XB-1 aircraft. That'll be a really historic milestone because it'll be the first time any independent company has ever built a supersonic jet. It's previously been governments and militaries only. This summer, seeing XB-1 in its flesh will be huge. And then looking forward next summer to being in the air and starting to set some speed records. That'll be the next milestone after that. If you want to follow along, we are at boomsupersonic.com. And on Twitter, we are at BoomAero, BOOMAERO. We do what we call transparent hangar, meaning we share a lot more than I think any other aerospace company about exactly what's going on. So you can go onto our website, click on XB-1, and you can see what's going on in our hangar almost in real time. You can see the parts coming together. You can fly through a 3D model of the aircraft and understand all the different components and how they work and why it enables this. And it's updated regularly, so you can actually see the progress as it's happening.
Wow. I will definitely check that out. Thank you so much for joining us today, Blake. This is an awesome conversation. And I would love to have you back on maybe after a few of these milestones are hit, because I think I, along with every other passenger and aviation geek, love the promise of supersonic flight.
It would be my pleasure. I've really enjoyed the conversation. Thank you for having me.
ARC believes that the information presented is accurate and was obtained from sources that ARC believes to be reliable. However, ARC does not guarantee the accuracy or completeness of any information, and such information may be subject to change without notice from ARC. Historical results are not indications of future results. Certain of the statements contained in this podcast may be statements of future expectations and other forward-looking statements that are based on ARC's current views and assumptions, and involve known and unknown risks and uncertainties that could cause actual results, performance, or events to differ materially from those expressed or implied in such statements.